Okay students, now is to read proof by various methods. So what are the different methods of proof? So that is what are the different methods of proof? So one is direct method. The second one is method of contradiction. Third one is method of contrapositive, and the last one is method of induction. So in mathematics we prove these four different methods. So coming to first, that is called direct method. So direct method is we start from LHS and prove to RHS, that is from LHS to RHS or from RHS to LHS. So this method is called direct method. So most of trigonometry or algebra we solve by direct method. The second method is called contradiction method. Contradiction method. So contradiction method is like, suppose we have to prove, say one example, take one example, root 2 is irrational. Prove. So how to prove root 2 is irrational? We contradict whatever we assume. First of all, we assume root 2 be rational. So which is, and we contradict our assumptions. That method is called contradiction method. So how to contradict? So root 2 is irrational, that means root 2 is equal to p by q. Say, so 2 is equal to p square by q square, that is p square is equal to 2q square. So p square is even, then p is even, and if p is even, then that is equal to 2k. So 4k square is equal to 2q square, q square is equal to 2k square. So q square is even, so q is even. So p is even, q is even, so that is a common factor. So both p and q are even. So that means there is a common factor which contradicts our assumptions. Our assumption is root 2 is equal to p by q and there is no common factor between p and q. But P and Q are even means 2 is common factor between P and Q. So, whatever we assume, we contradict our assumptions. That is called contradiction method. Next, coming to the third method, that is called contrapositive method. So, what is contrapositive method? So, contrapositive method, third one, is if we have to prove LHS to RHS. If we have to prove from LHS to RHS is same as to prove negation of RHS implies negation of LHS. Negation means it is not RHS, then it implies not LHS. So, this method is called contrapositive method. So, we read all these three methods in our school. The new method, that is called induction method. So, now we read a new type of proof, that is called induction method. So, induction method is a sequential method. So, induction method is a step by step method to prove method of proof. So, basically it has three different and induction method has three steps. So, it is applicable and is applicable to problems involving unknown variable, say n. So, it has an unknown variable, say n. So, what are these three steps? So, first step, step 1, have to prove it is true for n is equal to 1, and step 2, assume it is true for n is equal to k, and step 3, then to prove it is true for n is equal to k plus 1. Then basing on these three steps, so So, it is true for all n. So, induction method is a different type of method which is a step by step method of proof. So, what is it? Has basically 3 steps, and it is applicable to problems which involves a variable say n, because we put values and first we verify it is true for n is equal to 1, second assume it is true for n is equal to k, then to prove it is true for n is equal to k plus 1. So, what is a induction method? Suppose we know the arithmetic sum, that is 1 plus 2 plus 3 up to n is equal to n into n plus 1 by 2. So, this is arithmetic progression. Suppose we have to prove by induction method. So, here we prove by induction method because it involves a variable n. First we assume let P n is the statement 1 plus 2 plus 3 up to n, that is equal to n into n plus 1 by 2. First step 1, put n is equal to 1. So, if you put n is equal to 1, then it is P 1, and the left hand side is we put n is equal to 1. That does not mean 1 plus 2 plus up to 1, because it is increasing and this is wrong. So, we can not do like this. We put n is equal to 1 means here we put 1 in place of n and compare with the first term. If it is equal, then this is 1, and the right hand side, that is 1 into 1 plus 1 divided by 2. So, it is equal to 1. So, P 1 is 2. So, induction method, it is a step by step method, means if step 1 is not true, then we will not proceed to step 2. So, it is a continuous stepwise like algorithm, step by step solutions. So, step 1 is true means we move to the second step. Put n is equal to k. So, it is p k, which is put n is equal to k, and it is increasing order, means 1 plus 2 plus 3 sum up to k, that is equal to k into k plus 1 by 2. Suppose it is 1, assume P k be true, and step 3, put n is equal to k plus 1. Then to prove P k plus 1, which is, that is k plus 1, put n is equal to k plus 1, that is k plus 1, and the previous term compared to the previous term, that is 1 plus 2 plus 3 up to k plus k plus 1, that is equal to right hand side, that is k plus 1 into k plus 1 plus 1, that is k plus 2 by 2. That is, we have to prove this one. Pk plus 1 is sum of 1, 2, 3 up to k plus 1. We move from left hand side, that is 1 plus 2 plus 3 up to k plus k plus 1. Now, the sum of 1, 2, 3 up to k is k into k plus 1 by 2. So, for k plus 1 we use the result what is in the equation pk. So, here we put this result, that is the k into k plus 1 by 2 plus k plus 1. This is from equation 1. So, we simplify the result, that is k into k plus 1 plus 2 into k plus 1, that is equal to k plus 1 into k plus 2 divided by 2. So, this is your RHS. So, that means P k plus 1 is true. So, the first step we have to verify it is true for n is equal to 1. Second step, assume it is true for n is equal to k, and its third step, it is true for n is equal to k plus. So, by the method of induction, it is true for all n. So, induction method is a step by step method. It involves an unknown variable n. Now, we can take one more example. That is 1 square plus 2 square plus 3 square up to n square is equal to n into n plus 1 into 2n plus 1 divided by 6, again by induction method. So, here also it involves an unknown variable n. So, how to prove this method? Let Pn be the given statement, that is 1 square, 2 square, 3 square up to n square, that is equal to n into n plus 1 into 2n plus 1 divided by 6. So, whatever is given, that statement is a Pn. Step 1, put n is equal to 1, then P1 is 1 square and compare with the first term, that is 1 square. So, we cannot move further. Suppose n is equal to 2, then it is 2 square and previous term 1 square plus 2 square. Suppose it is 3 square, then the previous term will be 1 square, 2 square, 3 square. So, left hand side is 1 square and right hand side, that is equal to 1 into 1 plus 1 into 2 plus 1 by 6. So, left hand side is 1 and right hand side is 2 into 3 by 6, that is equal to 1. So, P1 is true. So, first step is satisfied. Then we move further. The second step, put n is equal to k, that is Pk 1 square 2 square up to k square, that is equal to k into k plus 1 into 2k plus 1 divided by 6. Suppose this is equation 1. Assume Pk be true. Next, the third step is put n is equal to k plus 1. Then to prove p k plus 1, that is 1 square 2 square up to k plus 1 square is equal to, the right hand side also put n is equal to k, that is k plus 1 into k plus 2 into 2 into k plus 1 plus 1, that is equal to 2k plus 3. Divided by 6. So, in all the induction method, the proof it must be a variable. The question should contain a variable, then we will have induction method. So, here we move from left hand side, that is 1 square 2 square 3 square up to k square plus k plus 1 square, and sum of these terms 1 square 2 square up to k square is equal to k into k plus 1 into 2k plus 1 divided by 6 plus k plus 1 whole square, that is from equation 1. So, we put the result from equation 1, that is 1 square 2 square up to k square is k into k plus 1 into 2k plus 1 by 6. Now, we simplify the result, the LCM is 6, that is k into k plus 1 into 2k plus 1 plus 6 into k plus 1 whole square. Now, from this 2 we take out the common k plus 1, that is k into 2k plus 1 plus 6 into k plus 1 divided by 6. So, that is equal to k plus 1 2k square plus k plus 6k plus 6 divided by 6. So, that is k plus 1 into k square plus 7k plus 6 divided by 6. Now, we can factorize 7k, that is k plus 1 k square plus 3k, sorry 6k plus k plus 6 divided by 6, and from these two terms we can take common 6k, k plus 1, k into k plus 6 plus 1 into k plus 6. Divided by 6. This is 2k square, that is 2k square plus k and 2k square plus 6k, that is 7k, it is 4k plus 3k, the factorization, that is k plus 1, 2k square by taking common 2k, that is k plus 2 plus 3, that is k plus 2 divided by 6. So, which is equal to k plus 1 into k plus 2 into 2k plus 3 divided by 6. So, this is a RHS. So, that means p k plus 1 is true. So, by the method of induction, it is true for all n. So, first step we have to verify it is true for n is equal to 1, assume it is true for n is equal to k, then using the result it is true for n is equal to k, we have to prove it is true for n is equal to k plus 1. So, finally, by the method of induction it is true for all n. So, we can have various examples, various proofs by induction method. So, one more example is your geometric progression GP, that is A plus AR plus AR square up to AR to the power n minus 1 is equal to A into 1 minus R to the power n divided by 1 minus R. Proved by induction method. So, this is a geometric sum, GP, geometric progression, and its sum. So, how to prove this? Again, let Pn be the given statement, that is A plus AR plus AR square up to AR to the power n minus 1, that is equal to A into 1 minus R to the power n by 1 minus R, provided R is not equal to 1. So, first step is put n is equal to 1. So, P1, if we put n is equal to 1, then P1 is A R to the power 0, that is A. So, it is a first term. and right hand side is a into 1 minus r to the power 1 by 1 minus r. So, left hand side is equal to right hand side. So, we have P1 is true. Then the second step, put n is equal to k. So, Pk will be a plus ar plus ar square up to ar to the power k minus 1, that is equal to a into 1 minus r to the power k by 1 minus r. Assume Pk be true. Then the third step, put n is equal to k plus 1. Then to prove p k plus 1, which is a plus ar plus ar square up to a r to the power k, that is equal to a into 1 minus r to the power k plus 1 divided by 1 minus r. So, we start from LHS, that is a plus ar plus ar square up to a r to the power k. Now, in all the induction method, we use the result Pk to prove Pk plus 1. So, Pk, the left hand side is a plus ar up to ar to the power k minus 1. So, we write just one previous term, that is a plus ar plus ar square a r to the power k minus 1 plus a r to the power k. So, just one term previous to a r to the power k, and the sum of a to a r to the power k minus 1 is equation 1. So, that is a into 1 minus r to the power k divided by 1 minus r plus a r to the power k, and this is from equation 1. Now, we can simplify the result, a into 1 minus r to the power k plus a r to the power k into 1 minus r by 1 minus r. So, from these two terms we take out the common a, 1 minus r to the power k plus r to the power k minus r to the power k plus 1 divided by 1 minus r to the power k term cancels out. So, that is equal to a into 1 minus r to the power k plus 1 divided by 1 minus r. So, this is your RHS. So, in Pk plus 1, we start from LHS using the result of Pk, we have right hand side. So, we conclude that P k plus 1 is true. So, by the method of induction, it is true for all n. Next we can have one more example, that is prove n into n plus 1 into n plus 2 is divisible by 6 by induction method. That is, product of 3 consecutive term is divisible by 6. So, let P n is equal to n into n plus 1 into n plus 2. So, in the first step we put n is equal to 1, that is P 1 is equal to 1 into 1 plus 1 into 1 plus 2, that is equal to 1 into 2 into 3, that is equal to 6. So, P 1 is divisible by 6. Obviously, 6 is divisible by 6. Then this subsequently second step, put n is equal to k. Then P k is equal to k into k plus 1 into k plus 2. So, the question is n into n plus 1 into n plus 2 is divisible by 6. So, any number which is divisible by 6 is again a multiple of 6. Suppose it is equal to 6m. Let. So, that means, so m stands for multiple. So, assume P k be 2. So, that means P k is a multiple of 6. Then coming to third step, if we put n is equal to k plus 1, then P k plus 1 will be k plus 1 into k plus 2 into k plus 3. So, here we put n is equal to k plus 1, that is k plus 1, k plus 1 plus 1, that is k plus 2, and k plus 1 plus 2, that is equal to k plus 3. So, we have to prove P k plus 1 is divisible by 6. So, using this result P k, that is k into k plus 1 into k plus 2, that is equal to 6m. So, we can expand into two terms, k into k plus 1 into k plus 2. plus 1 into k plus 1 into k plus 2. So, k into k plus 1 into k plus 2 plus 1 into k plus 1 k plus 2 into k plus 3. We can do like this. K plus 1 k plus 2, these two term with k and with 3. So, that is equal to k into k plus 1 into k plus 2 plus 3 into that is k plus 1 into k plus 2 into k plus 3 into k plus 1 into k plus 2. Now, k into k plus 1 into k plus 2, we assume that is equal to 6m from equation 1. Plus 3 into k plus 1 into k plus 2. Now, k plus 1, k plus 2 are two consecutive terms. And we know the product of two consecutive terms is a multiple of 2, because odd and even number come consecutive to each other. So, product of two consecutive number is always an even number and it is a multiple of 2. So, that is equal to say k plus 1 into k plus 2, that is equal to 2m, that is a multiple of m. So, that is equal to 6m plus 3 into 2m. So, by taking common 6 into m plus m. So, this implies p k plus 1 is also divisible by 6. So, p k plus 1 is also 2. So, by the method of induction, P n is divisible by 6 for all n. So, again here it involves an unknown variable n. So, we can use this to prove. Next we can take one more example which involves a unknown variable, that is say is divisible by 4 by induction method. Again we assume Pn be 5 to the power n minus 1. So, the first step is put n is equal to 1. So, P1 is 5 minus 1, that is equal to 4, which is equal to 4 into 1. So, 4 is obviously divisible by 4. So, P1 is true. That means P1 is divisible by 4. Next, the second step, if we put n is equal to k, then Pk, which is 5 to the power k minus 1. So, the problem is it is divisible by 4. Any number which is divisible by 4 is also multiple of 4. Suppose that is equal to 4m, let, where m stands for multiple. So, that means any number which is divisible by 4 is a multiple of 4. Then assume Pk, n is equal to k, that is 5 to the power k minus 1 is a divisible by 4 or it is a multiple of 4, suppose that is equal to 4m. Now, coming to this third step, if we put n is equal to k plus 1, then P k plus 1 is equal to 5 to the power k plus 1 minus 1. Now, using this result, Pk, that is equal to 5 to the power k minus 1 is equal to 4m. We have to prove this is divisible by 4. Now, we express it as 5 to the power k plus 1, that is equal to 5 to the power k into 5 to the power 1 minus 1. From equation 1, 5 to the power k minus 1 is equal to 4m. So, 5 to the power k is equal to 4m plus 1. Now, we use this result. So, that is equal to 4m plus 1 into 5 minus 1. So, that is equal to 20m plus 5 minus 1, that is equal to 20m plus 4, by taking common 4, that is equal to 5m plus 1. Suppose this number is equal to capital M. So, that is equal to 4m. So, this implies Pk plus 1 is divisible by 4, that is Pk plus 1 is true. So, by the method of induction, Pn is divisible by 4. Now, we have various problems, that is an induction method. So, induction method problems involves problems which contains a variable and we change the variables. Here it is variable is n So, this type of problems can be solved by induction method. Suppose a problem which does not involve any variable, we cannot prove by induction method. So, take one example, that is, suppose the problem is we have to prove sin 10, sin 30, sin 50, sin 70 is equal to 3 by 6. Suppose this type of problem, it involves no variable, it cannot be proved by induction method. So, induction method is applicable to those problems which involves variables. So, we can try some more examples. They prove by induction method. That is 1 cube, 2 cube, 3 cube up to n cube is equal to n into n plus 1 by 2 whole square. You can try this. Thank you.